The third and final formula that we looked at the end of last term was the gradient formula. And this formula is I guess one of the most important formulas that we're going to learn in our studies of coordinate geometry. And this formula is actually going to be the basis, or the idea of gradient is going to be the basis for the remainder of the methods course. Okay, from this term we move on to an area of maths called calculus, where we look at how we use gradients to find to look at curves and examine their properties. So this is a really fundamental formula, and we're going to keep using it throughout our studies. But for the moment, we're just going to look at how to find the gradient of a straight line. And again, to do this, we will just sketch in the triangle underneath the curve. And remember, this formula had a y2 minus y1 and an x2 minus x1 in it as well. And again, we talked about how that represented the lengths of these two sides. So this is like y2 minus y1. This side is like x2 minus x1. Some of you would have remembered this as rise and run. I like to use the letters delta y and delta x. That just means a change in y and a change of x. And the gradient is defined as the ratio of those two things. So to calculate the gradient of this line, we look at the ratios of rise and run, ratios of change in y and change in x. Change in y, delta y, is y2 minus y1. Delta x is x2 minus x1. Substitute our numbers in. y2, we've been saying, is the y coordinate of this point, which is 4. y1 is going to be the y coordinate of this point. The y coordinate of this point is 2. x2, of course, is 8. And x1 is 1. So I'm going to get 2 divided by 7 as my gradient. Now that looks about right. Remember, a positive gradient means we're going uphill if you were walking from left to right on this line. So imagine yourself on a line, someone standing here and moving from left to right, they would be going uphill. That means we've got a positive gradient. And I'll just slide back across again if it'll let me. No, it won't. There we go. And the number here, 2/7, is less than 1, so that means we've got a relatively flat gradient. Okay, remember a gradient of 1 represented 45 degrees, which would be running up in this kind of direction. Clearly this is flatter than that. So this line looks like it should have a positive 2/7 gradient. So we can be pretty sure that we've got that right.